In today's session, we are going to see infinity minus infinity form and 0 raised to 0, infinity raised to 0 and 1 raised to infinity form. Now, first we are going to check out the infinity minus infinity form. What are the working rules for infinity minus infinity form? First, suppose your function is your limit is of the form limit x tends to a fx minus gx, and limit of fx has a value infinity, limit of gx has a value infinity as x tends to a, then this form is called infinity minus infinity form. Now, we are going to rewrite it, the given limit, in the form of limit fx minus gx, where x tends to a, is equal to limit 1 upon gx minus 1 upon fx divided by 1 upon fx into gx. Now, this form is going to be 0 by 0 form, and since it is 0 by 0, so we are going to apply L'Hopital's rule. Okay. So, using L'Hopital's rule, we are going to evaluate the simple limit, and whatever the answer we get, that is our required answer. So, see, you have only two basic forms. First one is a 0 by 0 and second one is a infinity by infinity, and all the remaining are basically reduced to these two basic forms. Now, starting with the example, here evaluate the limit x tends to 1, 1 upon log x minus x upon x minus 1. So, we are starting with a L is equal to limit, given limit x tends to 1, 1 upon log x minus x upon x minus 1. Now, see, if you are going to put the limit, then log 1 has a value 0, that means 1 upon 0 will be infinity, and x minus 1 upon x minus 1, that will be a 1 upon 1 minus 1, that will be 1 upon 0. So, it will also has a value infinite. So, this is infinity minus infinity form. Now, what we are going to do, we are going to take the LCM, and if you are going to take the LCM, then you will have limit x tends to 1, x minus 1 minus x log x divided by x minus 1 into log x. Okay. So, this is now 0 by 0 form. Check out. If you are going to put x is equal to 1, then you will have 1 minus 1 minus log 1 has a value 0 divided by 1 minus 1 0 into log 1 has a value 0. So, applying L'Hopital's rule, that will give you 1 minus x minus log x, you have to treat as a multiplication rule, x as it is derivative of log is 1 upon x plus log x as it is derivative of x has a value 1. So, and in denominator x minus 1 as it is, log x is a derivative 1 upon x, and log x as it is derivative of x minus 1 is 1. Simplifying this one, that will give you limit x tends to 1 minus log x divided by log x plus x minus 1 into 1 upon x. Now, again, if you are going to put the limit, then this will be a 0 by 0 form. Now, it is 0 by 0 form. So, what I am going to do, I am going to rewrite it in a form of, by taking LCM in denominator. So, x will be going to the numerator, and the new term you will have is minus x log x divided by x log x plus x minus 1 in denominator. So, applying L'Hopital's rule, that will give you minus log x minus 1 divided by log x plus 1 plus 1. Now, see, if you are going to apply the limit, then the numerator has a value non-zero and denominator also has a value non-zero. So, you will have minus 1 divided by 2. So, this is your limit for infinity minus infinity form. Same manner, we are taking another example, limit x tends to 0, 1 upon x square minus 1 upon sin square x. Again, 1 upon 0, 1 upon 0, that means infinity minus infinity form is there. Take L is equal to given limit x tends to 0, 1 upon x square minus 1 upon sin square. So, what we are going to do is, we are going to take LCM, that will give you sin square x minus x square divided by x square sin square x. So, multiplying and dividing with x square in denominator. So, in denominator we are going to multiply and divide with x square, and that will give sin square upon x square as a value 1. So, the remaining limit we have is sin square x minus x square divided by x raised to 4. Now, this is 0 by 0 form. So, applying L'Hopital's rule, that will give you limit x tends to 0, 2 sin x cos x minus 2x divided by 4x cube. So again, if you are going to put the limit, then this is 0 by 0 form. Now it is 0 by 0 form, but we are 2 sin x cos x, we are writing it in a form of sin 2x minus 2x divided by 4x cube. So applying L'Hopital rule to this one, that will give you 2 cos 2x minus 2 divided by 12x square. And it is again a 0 by 0 form. So again applying the L'Hopital's rule, that will give you minus 4 sin 2x divided by 24x. So if you are going to put the limit, then sin 0 as a value 0, denominator is already 0, so it is 0 by 0 form. So again we are going to apply the L'Hopital's rule, and that will give you minus 8 cos x divided by 24. Sorry, minus 8 cos 2x divided by 24. And now the denominator part is already non-zero, so applying the limit, that will give you minus 8 by 24, and that is a value minus 1 by 3. Now we are going to check the three forms which are of the form something raised to something, that means fx raised to gx form is given, and if you are going to apply the limit, then it is either of the form 1 raised to infinity or infinity raised to 0 or 0 raised to 0. So these three are also the indeterminate form. See, 0 raised to infinity is not an indeterminate form. Please remember this thing. Now what we are going to do, suppose you have given limit x tends to a, fx raised to gx, and fx is greater than 0. So in that case, we are going to start with capital L is equal to limit x tends to a, fx raised to gx. Now if it is either of these three cases, then we are starting with taking log both sides. So if we are going to take a log, then since log is a continuous function, so it can go inside and outside of limit. So this can be written as a log of limit of x tends to a, fx raised to gx can be rewrite as limit x tends to a log of fx raised to gx. And if you are going to apply the properties of log, then power will be going in the multiplication of log. So that will give you log of capital L is equal to limit x tends to a, gx into log of fx. Now see, this form is 0 into infinity or infinity into 0 form. So you can apply the 0 into infinity form and evaluate this limit, and once you have the value of limit, suppose that value is k, then you will have log capital L is equal to k. But this is the value of log L, that means it is not the value of original limit, it is the value of log of the limit. So you have to take the antilog both sides, and that will give you capital L is equal to e raised to k. Please remember, as we have taken log, so at last we have to take antilog to find the original limit. That is the main thing in these three type of indeterminate forms. Now we are going to check out the example. Prove that limit x tends to 0, a raised to x plus b raised to x plus c raised to x divided by 3 whole raised to 1 upon 3x has a value a plus b plus c whole raised to 1 by 9. Now let capital L is equal to limit x tends to 0, a raised to x plus b raised to x plus c raised to x divided by 3 whole raised to 1 upon 3x. See, if you are going to put the limit, then a raised to 0 as a value 1, b raised to 0 as a value 1, c raised to 0 as a value 1. That means you have 1 plus 1 plus 1, that is 3 upon 3. And so that function is going to have a value 1. And in numerator, in a power 1 upon 3x, if you are going to apply limit, then 1 upon 0 will be infinity. So it is 1 raised to infinity form. That first you have to check out. And since it is 1 raised to infinity form, so we are starting with taking log both sides. So if you are taking log both sides, then that will give you log of L is equal to log of limit of a raised to x, b raised to x, c raised to x divided by 3 whole raised to 1 upon 3x. Now since log is a continuous function, so we can interchange the log from the limit. So you will have limit x tends to 0, log of a raised to x plus b raised to x plus c raised to x divided by 3 whole raised to 1 upon 3x. Now use the property of log, and 1 upon 3x will be in the multiplication of log. So whatever the form we have, this is 0 into infinity form, or infinity into 0, because 1 upon 0, 1 upon 3x, that will be 1 upon infinity, and log of 3 by 3, that means log of 1 has a value 0. So it is infinity into 0 form. So either write down that in the form of 0 by 0 or infinity by infinity. We are going to write this in the form of 0 by 0 by taking 3x in the denominator. So that will give you limit x tends to 0 log of a raised to x, b raised to x, c raised to x divided by 3 log of a raised to x plus b raised to x plus c raised to x divided by 3 whole divided by 3x, that is 0 by 0 form. So if we are going to apply the L'Hopital's rule, and if we are going to apply the L'Hopital's rule, then log as a derivative 1 upon x, that means 3 upon a raised to x plus b raised to x plus c raised to x into the bracket a raised to x log a plus b raised to x log b plus c raised to x log c divided by 3 whole divided by 3. Now since denominator is already non-zero, so apply the limit to the given terms, that will give you 1, 3, 3 cancel out, and you will have 1 upon a raised to 0, b raised to 0, c raised to 0 into the bracket a raised to 0 log a plus b raised to 0 log b plus c raised to 0 log c, and that will nothing but 1 upon 3 log a plus log b plus log c upon 3. And if you are using the properties of log, then you will have log a plus log b plus log c is equal to log of abc into 1 by 9. So we have to take a anti-log. For that we have to take 1 by 9 in the power of ABC, and that will give you log of L is equal to log of ABC whole raised to 1 by 9. Taking anti-log both sides, that will give you capital L is equal to ABC raised to 1 by 9. Same manner, the another example we have written is limit x tends to 0 1 upon x raised to 10x. Now see, x tends to 0, that means 1 upon x has a value infinite, and 10 0 has a value 0. So this is the infinity raised to 0 form. Now infinity raised to 0 form, so again taking log both side and using the property of log and taking power in the multiplication of log, that will give you log of capital L is equal to limit x tends to 0 10x into log 1 upon x. Now this is 0 into infinity form. So either you have to write down it in the form of 0 by 0 or infinity by infinity. Now 10x will be written in the form of 1 upon cot, and log 1 upon x is equal to minus log x. So that will give you limit x tends to 0 minus log x divided by cot x. And if you are applying the limit, then log 0 has a value infinity, cot 0 also has a value infinity. So this is infinity by infinity form. So applying L'Hopital's rule, so numerator has a derivative in numerator, denominator has a derivative in denominator, and that will give you limit x tends to 0 minus 1 upon x divided by minus cos x square x. Now cot has a derivative minus cos x square, minus minus cancel out, cos x square will be replaced with 1 upon sin square, and simplifying it, that will give you limit x tends to 0 sin square x upon x. So that is nothing but multiply and divide with x, that will give you sin square x upon x square into x. So sin x by x is a value 1. So 1 into 0, that will be a 0. So log of L has a value 0, and that will give you, by taking anti-log both sides, that will give you capital L is equal to e raised to 0. That means it has a value 1. Okay. Now the another form we have taken is limit x tends to 1 minus x square raised to log 1 upon log 1 minus x has a value e. Now what we have, this form is nothing but 0 raised to 0 form. Why? Because 1 minus 1 will be 0, and 1 upon log infinity, log 0 has a value infinite. So log 0 has a value infinite, so 1 upon infinity will be 0. So 0 raised to 0 form is there, and that's why we are starting with taking log both side and using properties of log, that will give you limit x tends to 1 upon log of 1 minus x into log 1 minus x square. This is 0 into infinite form, and 0 into infinite, rewriting it in a form of log 1 minus x square upon log 1 minus x. Now, applying L'Hopital's rule, that will give derivative of numerator in numerator, denominator in denominator, and you will have log of, limit x tends to a, log has a derivative 1 upon, that means 1 upon 1 minus x square into 1 minus x square has a derivative minus 2x. So, minus 2x upon 1 minus x square divided by minus 1 upon 1 minus x. Simplifying this, denominator going to numerator, and simplify this term, that will give you 2x into 1 minus x divided by 1 minus x square. Factorize the denominator, 1 minus x square as a factors, 1 minus x, 1 plus x. So 1 minus x will be cancelled out from numerator and denominator, and the remaining part you have, that is 2x upon 1 plus x. If you are going to apply limit, then this has a value 2 by 2 and has a value 1. So log L has a value 1, so taking anti-log both sides, so capital L has a value e raised to 1, and that will give you the answer. These are the some examples which we have to try yourself, and if you have any query or any doubt regarding this topic, then please feel free to contact me. Thank you.